All right. So we talked about here solvation of ionic or acidic compounds in water, in a polar solution like water. Okay? Let's look at solvation of something that's not ionic or acidic. We looked at a moment ago, we talked about sugar. Okay, we said that a really simple sugar like glucose has the formula C6H12O6. Okay? Are there any metals in here at all?
No.
So it can't be ionic without a metal, non-metal compound or the presence of a polyatomic ion. Any polyatomic ions in here? No. No. There's no, this is not ionic. You either have to have metal bonded with non-metal or you have to have a polyatomic ion in the formula to recognize that as being an ionic compound. This is not ionic. This is completely covalent. That's right. There's no hydrogen on the front. Okay? Now I'm oversimplifying a little bit because you could put the hydrogen on the front, but it's not. This is not an acid. Okay? At least there actually could be an acid with this formula. We're not going to get into that. Okay? This is not acidic. It's covalent. All right. So what happens then is in this sugar. In fact, let me just look up the structure of glucose really quickly here. You don't have to know the formula for glucose, but it might be helpful for us to talk about it just very briefly. Let's see. There we go. That's the one I'm looking for. So a glucose has one of those carbon ring structures. Okay? So that's kind of a hexane, but there's an oxygen in here instead of a carbon somewhere. Okay? And there's OH groups on here. There's a carbon here and an OH. Got an OH here. Got an alcohol. These are alcohol groups, right? OH. OH. We talked about it in the last unit. Those are alcohol groups. Okay? So that's a sugar. That's a glucose. Now we could sort of break the structure out. Okay, sort of break it apart, separate it a bit. But let's see, something doesn't look right. There's supposed to be a double bonded oxygen somewhere. No, I guess not. Thought there was a double bonded oxygen somewhere. Oh, I see where it is. Okay, all right. So, in this glucose then, we said that when we had an alcohol like CH3, CH2, CH2OH, that this end of the molecule is really polar, and it goes through what's called hydrogen bonding with water. It makes this soluble in water, even though this end is polar and this end is nonpolar. This end is attracted to water. This end is not attracted to water. Okay? Well, the same is kind of true here, where this part of the structure in here was just carbons and hydrogens, but out here these OH groups are attracted to water. And there's a polar attraction with this oxygen right here. So that provides a kind of a handle. Now, it's kind of a, I don't know, maybe not such a nice thing to think about, but you can think of these kind of like handles on a big box, like a casket or something. You've seen people carrying a casket in. They're big handles on the sides, right? Yeah. So 6 guys can grab the handles and carry the thing, correct?
Correct.
Okay? You've been to funerals, you've seen that? Well, traditionally, there are 6 handles on a casket, and the pallbearers carry the casket with the handles. And in some really formal type of things, they'll put it on their shoulders, but they're still holding on to it with the casket handles. Okay, maybe I can do that in a minute, but I can't do it right this second.
She'll figure it out.
All right. So, listen. So let's put this water molecule out here by itself, and let's talk about what happens if we put it in water. Okay? So we've got this OH group, and you got an OH group, and another OH group, another OH group, and then we've got a carbon right there, but an OH group up here. Water molecules, H, O, H, remember, are partially negative over here where the water is, and partially positive over here on the sides where the hydrogen is located. This is also partially negative here and partially positive here. Okay, this actually is partially negative here. So partially negative, partially positive. Partially negative, partially positive. Partially negative, partially positive. Partially negative, partially positive. Okay, getting a little bit complex here, but look, if there's a partially positive end, then it's going to have a hydrogen bonding attraction to the water molecule's oxygen end. Okay, and this one, and up here, this is going to have a hydrogen bonding attraction to the hydrogen end, which is partially positive. Okay, and so you can, you got water molecules that can join up here, and here, and here, in a hydrogen bonding fashion. Not that they join up covalently or anything, but they're attracted to these parts of these structures here.
Okay.
I was trying to write it down while you was talking.
All right?
Trying to look up more little numbers.
Okay, well there's attractions going on between all these places in water molecules. Okay? So this is a polar attraction. This is a dipole-dipole attraction. In the last unit we talked about dipole-dipole attractions. Okay? There are dipole-dipole attractions between each of these water molecules and each of these OH groups and these oxygens here. Okay? In fact, the hydrogen bonding is really somewhere between just a polar attraction and actually being covalent. They're actually slightly sharing electrons. Yeah. Yeah, you just left and got some water a while ago. You know, you need to be in here more than you do out there. You can't. You don't learn unless you're in here.
Hey, so I got a question.
Okay, go ahead, Will.
Alright, you see when you got at the bottom.
Okay, hold on a minute, please. Be quiet.
Alright, you see at the bottom when you got H and then the low hydrogen, the water molecule.
Down
At
here?
the bottom, no, like right over there. Go over a little bit.
This one.
Yeah, right there. Now what's happening?
That's a water molecule, same as this.
I know, but what happened?
This is that's just the hydrogen part right there. Just like I'm drawing this, only I'm doing it with this sort of molecular structure. Okay, it's the same stuff. Okay. Yes, it's written different. Same stuff though. We used it when we're doing the solvation of a salt a minute ago. We used the structures that look like that. Okay. Well, this solvation then isn't water molecules sort of nestled around an ion, the way we did it when we had ionic or acidic particles. This is hydrogen bonding to these hydrogen bonding groups on the sugar. And so this is more like the pallbearers with a casket, where the pallbearers grab hold of the handles and pull them into solution. Okay? So the crystal sugar is a crystal too. We looked at table salt under those microviewers, and we saw it was a crystal. If you look at table sugar, you'll see a structure like that. And so it's crystallized when it doesn't have any water in it, and you put it in water and stir it up like stirring up tea with sugar, and it starts to pull them apart because of this kind of solvation. This is also solvation. It's just a different kind of solvation. Okay? It's also solvation. It's a different kind of solvation.